And each and every PV array, we have PV panels, cables, all those things. These are all the various types of faults that occur in a PV array panel, which we never mm, come across. And here, you can see these possible faults that occur in life of a PV panels. So here, if you look into this graph, we have three categories: infant failure, midlife failure, wear out failure. So, this infant, if you look into this figure, there is a line after midlife failure. In this middle, that is warranty. That means whenever that panels are manufactured, that manufacturer will gives you warranty and guarantee for this product everywhere. So infant failure means at the time of manufacturing, at the time of erection, which we come across this type of failures, infant failures. And the midlife failure means the failures which come under normal operation. That means after inception, after working that PV panel for some days, that is midlife failure. And wear out failure means these are all the long term. So in the long term failure, we can see there are only two types for delamination corrosion of panel only. Remaining all these things, faults that occur in there, this infant failure and midlife failure. And the next coming to the wind farms. The second category of so renewable power generation is wind. It is an indirect type of solar power generation. Wind is a indirect form of solar power generation, but it is continuous. Whereas solar is a direct form of solar, but it is not continuous. We can use the solar only in the daytime, but whereas the wind can be used all the times. It is indirect form of solar energy. So here, the fault detections in the wind turbine, wind farms, mills come are vibration analysis. So as that wind farms are, windmills are erected at the outdoor, so they are also subjected to wear and tear conditions for this natural calamities and natural disasters, all those things. So therefore, that particular device cannot be has to withstand that mechanical forces, all those things, natural calamities. So in that aspect, this AI is used to monitor the vibration of the turbine. At the same time, it is to detect that bearing and any issues in the blade and the gearboxes. So these are all the main components. If these components are proper, then we can make the wind fan to run properly and efficiently. If is any defect, we cannot run the system, that run the fan. And then sound pattern recognition also is one of the important thing. It identifies the mechanical problems and structural defects in the rotating components. And then SCADA, supervisor control and data acquisition systems. So machine learning is used to spot all these things, that is temperature, pressure, and output power. So that mainly the thing is depending upon the output, the demand only, we have to balance the power generation for that purpose. So by using artificial intelligence, we can handle this grid frequency up to 80 to 90%. That is deviations can be reduced. That frequency deviation can be reduced, and we can maintain this grid as stable, and also we can make the system as reliable. How we are depending on the coal and the nuclear fuels, just like we are relying on, we can make that this system also system as grid stability by using this AI. So why we are incorporating renewables to the power grid means so to make the system stable. So by introducing this incorporation of into power grids increases notable uncertainties in energy production and load demands, and also thereby reducing the posing the challenges to grid stability. And the second thing is stochastic simulation, which is conducted with sufficient number of iterations, can identify potentially severe scenarios that make grids unstable. Next one is the inverter. So inverter is a device you know very well about converts the DC to AC, which we are using for solar panels. Because sun irradiance which is coming, solar panels absorb that sunlight from the sun, and that is converted by photovoltaic theory, that is converted to DC, and again that DC has to be converted to AC with the help of inverter. So that inverter is also optimization also done with the help of AI, the dynamic adjustment, and how to maximize the efficiency and grid compliance. Here you can see the flow chart showing the relation between the smart grid, renewable source, and power quality in figure A. The renewable sources are using quality of power grid, power quality of power, and it's up to smart grid. Both are cyclic process. And here you can see the typical structure of a smart grid. You know very well about the smart grid, which is a connection of so many things. Smart grid is a two-way communication system. And then coming to MPPT, as we all know that this maximum power point tracking. So as that you know that solar power is not continuous due to the variation of the sun. So we to identify this maximum power, we are using MPPT controllers. So this MPPT controls extract the maximum power from the solar panels under varying conditions. So uh, for this MPPT controls, you are applying AI algorithms, artificial techniques. So through intelligent algorithms, that is machine learning algorithms. So the three things that tracks is irradiance adaptation, temperature compensation, and partial shading solutions. So here AI predicts the optimal operating points, that is sunlight changes throughout the day. Uh, that is from day sunrise to sunset, that changes. This irradiance also will be varying. So that by using this AI techniques, we can predict the operating points for that irradiance adoption. And by using MML, we can adjust the temperature effects on the panel voltage to maintain peak efficiency in all weather conditions. At the same time, uh, partial shading solutions. Advanced algorithms navigate the complex shading patterns to find global maximum power points and not just local peaks. here you can see this summary of the MPPT techniques, different types. So here MPP techniques, different types of techniques we are using, and we are taking different types of statistics: efficiency, convergence speed, oscillation, cost, implementation complexity, sensor parameters, track real MPP, reliability. So looking at all those things, P and O, different types of MPPT techniques, P and O, ANC, FSCC, FOC, these are all different types of techniques adopting. So here finally you can see ML efficiency by using machine learning, efficiency you're getting at 98.9%. Convergence also very fast. Oscillations are nil. Expensive. Cost is also expensive. Implementation digital, sensor multivariable, and real track and reliability high. That means overall, comparing all these things, we can prefer machine learning algorithm uh, algorithm techniques for this techniques. So you can see here P and O having medium efficiency 95%, convergence slowly varies, oscillations nil, and the cost is relatively low. Implementation is also low. Sensor parameters are low, and track is there is a real-time tracking of this MPPT, and it is low reliable P and O. And similarly, INC, it is also maximum giving efficiency 98%. Convergence also variable, oscillations nil. It is expensive. Implementation complex is medium. Sensory parameters are voltage and current. Only two. And real-time tracking is also there. And the reliability is very medium. That means you are not giving complete authentication. We are giving partially. And then the FSCC is very poor in efficiency, medium in convergence, oscillations are there, cost is inexpensive, medium in implementation, parameters are only current, real time cannot track, and less reliable. Similarly, FOCV also. PSV is somewhat having efficiency 99.8. The convergence is very fast, and the oscillator nil, expensive, implementation very partial. Multivariable parameters. Multivariable means all parameters, temperature, voltage, current, etc., etc., can be measured. And the real-time tracking is also there, and also is reliable. Similarly, FLC is also it is efficiency maximum. Maximum in the sense we can say here around 90 to 95%, not above, not less than 90, but in between 90 to 95%. And convergence is fast. Oscillations are there, expensive and high distal and varies as and reliability is also medium. This A and artificial neural networks. So the same thing. So similarly, all these techniques, fuzzy logic, the map, so a single formulation, OADC and ML, all these are different types of MPP techniques which we are adopting. So looking at these techniques, we can say that ML is the best suitable for this renewable integration. So by So in this, by using AI and ML, artificial intelligence machine learning algorithms, MPPT can be optimized. So that the research, what the research is going to say that there are significant benefits by integrating AI-driven MPPT controllers into PV systems, offer a more efficient, adaptive, and intelligent solution to power optimization. Similarly, the machine learning, fuzzy logic, and genetic algorithms provide enhanced performance by enabling real-time adjustments to fluctuate solar radiance, temperature, ensuring to give maximum power and system stability. And third one is AI-based MPT control performs conventional techniques, offering improved efficiency, reducing energy losses, higher adaptability, especially in dynamic environment. And also innovative approach holds the potential to revolutionize solar energy systems, particularly in rural industrial applications, contributing to the advancement of a sustainable energy solution. Further, future work will focus on refining these AI models and expanding the application of this technology in various renewable energy systems. So, in such a way, this AI and ML plays a crucial role in this renewable energy integration. So, the future is intelligent and sustainable. Why? Because means smarter predictions, stable grids, proactive maintenance, optimized performance. Smarter predictions means enhanced forecasting accuracy. That means forecasting is very important. Based on the present situation data, we can forecast the future things. So the smart predictions, stable grids, by using this AI and ML, we can make this grid to be stable, so that we can supply like grid will be stable, and proactive maintenance. So proactive maintenance, earlier fault detection before after before occurring the fault only we can identify this one thing, faults. That is proactive maintenance. And then optimized performance. Optimized performance means with the minimum energy we can to supply maximum power. That is maximum energy capture. So that is optimized performance. So this AI is very good in transforming renewable energy into intermittent resource into a reliable, efficient, and intelligent power system by combining machine learning with clean energy technologies. We are building a sustainable future powered by data-driven innovation. So coming to this AI developments, AI is employed. AI is used to enhance the computational techniques, energy, and generate massive amounts of information. So the integration of this big data and AI is regular for intelligence instrument to successfully manage and evaluate a huge amount of information produced by energy networks. And also AI is a hybrid of various forms of energy with the IoT architecture, and intelligent grid itself is also controlled by artificial intelligence. And similarly, this AI is used to improve smart grids, intelligent load characteristics, load control, load shifting, detecting power outages in the intelligent grid atmosphere, preventing cyber threat. And further investigation, it is used to, there will be this for efficiency. AI is widely used in renewable energy for efficiency planning, estimation, regulation, and transmission. And also, it is necessary to develop AI network services that could appropriately detect electricity effectiveness and funds for clients and companies in the coming years. So the dispersed power basis and dispersed generation, this AI would incorporate renewable electricity into the grid and enable considerable discretion. Finally, AI is widely used to practical in all renewable studies like solar PV systems, winds, and combination for planning, construction, administrative protection, and regulation, as well as transmission. So therefore, it is necessary to develop AI software packages that could appropriately recognize the electricity effectiveness and investments for individuals and trades in the coming years. And the connection and optimization of renewables with the electricity network utilizing AI technology can improve flexibility, dependability, electricity constancy, profitability, burden scheduling, and so on. So AI has the potential to change numerous power industries and boost development in the next years. And this is about this one, and these are all the references. This is a brief about my topic, today's topic.
Thank you, sir. Thank you for your valuable information. Participants, any queries? Please, participants, any queries regarding today's session? You can use
This is
chat box
very,
also.
I am very new to this particular topic. I was very good in other areas, but I was supposed to take this as a challenging task, and I have given. Sorry if there are any uh, lapses in my presentation. Please bearing. Thank you
No,
for bearing
no,
me
sir,
for
no,
this
sir.
one
It's
and a half
a
hour.
very
Uh, I have taken as a challenging task, sir, because I want to improve myself. So therefore, I have within a short span, I have made the presentation with some sources, and I gave the presentation. I don't know whether it is benefit for you, how far
it's a really
it has
benefit
been
to us.
induction.
It's very useful to.
Okay, sir. If there is anything,
Is any queries regarding this section? Participants are requested to ask. So chat box. So which ML technique can be used? How can we use ML techniques in renewable integrations?
sir, which ML technique? Sir, in ML, there are so many techniques, sir. That's what in the beginning itself I told you. I'm just presenting the outline skeleton, but in deep, there are so many regression methods. There are so many techniques, sir. Uh, I have not deeply gone into that particular techniques. If you hold on, I will just come in 1 minute, sir. 1 minute, please hold on. I will give you the information. Um, minute, sir. I will show one of my presentations, sir, which I will use for my BTech
Okay,
students.
sir.
I will.
Okay.
That is. Sir, here techniques are there are the so for forecasting we are using regression models, linear regression, polynomial regression, ridge and lasso. There are three types of regression methods. Um, for this, what you can say, grid stability and the power quality monitoring, we are using reinforcement learning, sir. Reinforcement learning, and again that there are subtopics: reinforcement learning, Q learning, deep Q networks, policy grid methods. Likewise, there are clustering techniques, support vector machines, auto encoders are there. And similarly, for fault detection in solar wind farms, SVM, random forest, logistic regression. Again, in deep learning, we have CNN, conventional neural networks, auto encoders, LSTM, signal processing. Likewise, there are genetic algorithms, particle swarm optimization, anti-call optimization, gray wolf optimizer. Likewise, number of there, sir. So there are likewise we have no many for each and everything category. We have different types of algorithms. Depending upon that particular application, we use this one. So among all these things, machine learning is the best one, sir. We are preferring.
Okay, sir. Thank you, sir. Thank you for your valuable information, sir.
Thank you, sir.
Thank you very much, sir. Thank you all the participants. Tomorrow we have an last session, day 6, at optimization techniques for power system using AI. It is for 2 to 3:30. After 3:30 to 4, you have an validity section. I requested to all the participants join and give your valuable feedback to the 1 week FDP on applications of AI to the power systems. Thank you. Thank you very much. Thank you, sir. Once again.
Thank you, sir. Thank you, sir. Okay. Can I leave, sir?
Okay, sir. You may leave.
Okay, right, sir.
Yes. I request all the participants to fill the feedback form is posted in chat box as well as group also.